Okay, so this is where we left off in part 1. I'm just gonna continue naming hydrocarbon. Okay, so for this structure here, I'm gonna start from the left and go all the way this way. Okay, that's because this branch is closest to the right terminal. So I'm counting my carbons: 5, 6, 7, 8, and 9. Alright, so parent chain is no name. And then on carbon 2, I have chlorine. Chlorine is going to become chloro, okay? Because it's a halogen, and every halogen will follow this. Fluorine will be fluoro, iodine will be iod. And then on carbon 3, I have a metal. Remember, methane becomes metal when it's a branch. And on carbon 6, I have metal again. Alright, so when you're writing the whole name or the full name, it will be 2-chloro, 3,6 dimethyl. Remember that? No name. Okay, because on carbon 3 and on carbon 6, the two branches are identical, so you just put the prefix di, and yeah, and use alphabetical order. That's why I have chloro first and then metal after. Okay, so next we are going to draw the structure. Okay, so we have two names. We will draw the structure for these two names. For part A, the name is 2,2-dimethylbutane. So what you're going to do is, when you're drawing the structure, always start with parent chain. Okay, so the parent chain is butane, which is 4-carbon compound, and then on carbon 2 you have 2 times metal. Okay, so it's dimethyl. If I'm counting from the left side, having this my carbon 1, and on carbon 2 I have 1 metal and another metal. Okay, or I could count from right side, and this would be my carbon 2. Okay, you would have 2 metals here, but since I started from the right side, there I have it there. Alright, so next we have 3-ethyl 2-methyl hexane. So your hexane, 1, 2, 3, 4, 5, one more, 6. Okay, so this time I'm gonna count my carbons from the right side, just for a change. Okay, if I count my carbons from here, carbon 2, carbon 3, carbon 4, 5, and 6. So on carbon 3 I have an ethyl. Okay, so on carbon 3 I have an ethyl. On carbon 2 I have a metal. Okay, so there's my metal. Okay, okay, so when you have branches that have 3 carbons or more, then you might think about isomers. Okay, so isomers, to recall, is defined as 2 chemicals with same chemical formula but different structures. Okay, so these two here, they're isomers to each other. Okay, why? Because when you count the number of carbons, they're the same. So this one has 1, 2, 3 carbons, this one has 1, 2, 3 carbons. They're the same number of carbons or same chemical formula but different structures. Alright, so if you are curious about what R is just any parent chain. Okay, so you can have any parent chain but then this as your branch. Alright, or all of these are isomers to each other. Okay, so if you have branch on your parent chain that looks like this, then they will be isomers to each other. So these are all 4-carbon branches that are structured differently. Okay, so 4 carbons, 4 carbons, and 4 carbons. Okay. So what's important about these is each of the isomers will have their own names. All right, so you will have to remember these. If you see them on your parent chain, make sure you name it accordingly. All right. All right, let's practice these. Just a couple practice questions here. Okay, so let's say we have structure that looks like this. Here is a fluorine, and then here is 3 carbon branch. All right, so we are going to count our number of carbons. Again, I'm going to start counting from the right side because the branches are closer to the right terminal carbon. All right, so remember that. So it's a hexane as my parent chain, and then on carbon 2 I have a fluoro. On carbon 3 I have a isopropyl. So F comes before I. Okay, so that's an I. That's why we are gonna start writing the full name, as in starting with 2 fluoro, 3 isopropyl hexane. Okay, so just remember that isopropane becomes isopropyl because it's a branch, and fluorine is a halogen, so it becomes fluoro when it's in a branch form. All right, another practice question I have is this one is iodine, this one is chlorine, this one is a 4 carbon branch. All right, so in this case, regardless of me counting from left side or right side, the 4 carbon branch is in the center. It doesn't matter. What I have to think about is iodine and chlorine. Where should I start from? So when you have some case like this, you're going to consider the element with higher or larger atomic mass. Okay, so atomic mass, higher atomic mass. So in that case, iodine has a higher atomic mass compared to chlorine, so you're gonna start from the terminal closer to iodine. Okay, so count your carbons like this. Sorry, this is 6, this is 7. All right, so iodine is our priority because it has a higher atomic mass. So again, you see this because each terminal you will have on the second carbon the halogen. That's why you're going to consider the atomic mass. Okay, so our parent chain is heptane, and then you have 2 iodo, 4 so isobutyl. Okay, and then we have 6 chloro. Right, so to write the full name, then you start with chlorine because that's considering the alphabetical orders. Okay, so to write the whole name, then you start with 6 chloro, 2 iodo, sorry, that should be 2 iodo, 4-isobutyl heptane. Okay. Okay, so what we have is naming cycloalkanes now. So to name cycloalkanes, simple cycloalkanes, you just start with counting number of carbons. You take the root name and then add cyclo in front of that. Okay, so for example here we have 4 carbons. That should be but, and then add the ane, and then add the cyclobutane. All right, and then here you have 6 carbons here, 1 2 3 4 5 6. It's hexane, and then add the cyclo, it will be cyclohexane. All right, so with the cycloalkanes, you can either have them as a branch. In this example, when you have it as a branch, it's going to be cyclo. Here's 3 carbons, so cyclo pro. Remember it was propane, now it's going to be propel because it's a branch. Okay, and then our parent chain is 1 2 3 4 5 carbon, so it's a pentane as my parent chain. All right, so then you have the branch on the second carbon, so it's going to be 2 cyclopropel pentane. Okay, that's simple. So when you have it as a parent chain, then you start by numbering your carbons starting from the branch. Okay, so I could go this way numbering, or I could go this way. Doesn't really matter because there's only one branch. When you have 2 branches, then you have to think about where all of your branches are going to have the lowest number of carbons. Okay, so then depending on where you have the next branch, you either go this way or that way. You want all your branches to have the lowest number of carbons possible. All right, so for this one now, the branch is metal, so you're just going to simply call it metal cyclopentane. Okay, it's a cyclopentane with a metal group. So I hope this video was useful, and I hope you liked it. Our next 2 videos will be on naming alkane and naming alkyne. So please subscribe to my channel. Thank you.